introduction of the model and analysis of this paper. In this video, I'm going to introduce the model. Okay, so we're going to sell information goods to consumers. So let me first describe what do we mean by consumers. Suppose consumers are somewhat different and their types are distributed within a region between theta lower bar and the theta upper bar. So this is a continuous type problem. As a principle, I do not see what's the agent's or what's the consumer's type. So I believe the distributions for these types are denoted by capital F and small f. Okay. There's an assumption saying that small f is greater than 0 for all theta, and that's not a big deal. It's just a technical assumption. Okay, so how do theta determines consumer's preference? Is by entering the net utility function. Okay, so we say when a consumer of type theta consumes Q units of the goods by paying P, the net utility would be U of Q theta minus P. Okay, here Q is the quantity and the P is the price or the payment. Okay, so different consumers with different theta will feel different things when they choose the same quantity and the price. Okay, so theta determines their utilities. Here we do not use specific form for U. Okay, and we say U is going to satisfy several assumptions or properties. Eventually, you're going to see that those assumptions we made on U is just mild or general. Okay, not a big deal. It's just something we need to regulate our problem. Okay, to remind you, what we did for the monopoly pricing problem is to say that U of Q theta is theta times V of Q. Okay, when we were doing our monopoly pricing problem, we used this specific form of U function. In this paper, we do not say U must be like this. Okay, we allow you to be more general, but you need to satisfy the following assumptions. The first one is that U is strictly concave. Okay, non-decreasing and concave. So your U would be a function like this. Okay, this is Q, and this is U. Yeah, so natural. And then we say for a given consumption quantity or for a given Q, high type has a higher utility. Okay, so that means that's why we call a higher theta a high type, because when theta is higher, they prefer more quantities. Okay, and then we have the third assumption. We say that for all the agents, those high types enjoys higher marginal benefits of consumptions. So what does that mean? We say that consider this quantity first. This is your utility. The first order derivative with respect to Q means your marginal benefit of consuming one more unit. Okay? So this is your marginal benefit for eating one more unit. And this, no matter what's the quantity, this marginal benefit is going to be larger for higher types. Okay? So if one guy is of higher types, then his marginal utility or marginal benefit will be higher. Okay? So somehow these two conditions are just saying high types are those guys who prefer more or higher consumptions. Okay? The fourth one is somehow more interesting or more complicated to explain. So this is a blah blah blah. Also, let's see what's this. First is about this quantity. This quantity is the second order derivative with respect to Q divided by the first order derivative with respect to Q, and then reverse the sign. this thing is defined as the absolute risk aversion or the degree of aversion, okay, in economics. So what does that mean? We know if U function is something like this, if U function is a concave function, we say this agent or this person is somewhat what? Risk averse, right? We discussed about this in about the third week of this semester. When U is concave, this guy is risk averse. And we want to find a way to compare if two persons both have concave utility functions, who is more risk averse? Okay, that's the question. So we define this coefficient as absolute. Okay, we define this absolute risk aversion coefficient or factor, so that a larger ARA means this guy is more risk averse. Okay, so if that's the case, here we are saying that high types are less risk averse. Okay, somehow that may fit your intuition. If I really like a product, okay, then I don't care about risk that much. Okay, so that's the assumption. Here I'm going to give you some tiny examples. Okay, the example is here. Okay, here we have two utility functions. The first one is linear, it's just u of x is x. The second one is concave, 2x minus x squared. Okay, this is 1. This is 1. Let's try to calculate their absolute risk aversion coefficient. For the first one, okay, the second order derivative is always 0. So the coefficient is always 0. For the second one, okay, then it depends on this thing. So let's try to calculate this. The first order derivative, we get this. The second order derivative, is 1 minus 2x. The second order, 2 minus 2x. The second order derivative is just negative 2. So we get 1 minus x. And then 1. With this in mind, if x is between 0 and 1, we know this thing is greater than 0. So that means the second guy is more risk averse. Okay? Intuitively, that just means this curve is more is curved in a more serious situation. Okay? So in this case, it justifies why do we say this concave guy is risk averse? Because we know this linear thing tells us this person is risk neutral. And a concave function means this person is risk averse or is more risk averse than a risk neutral guy. Okay? And our calculation satisfies what we mean here. Okay. Actually, you don't really need to worry about these assumptions. I'm introducing them to you just to expand your knowledge and also to make sure that you can read the paper at least up to here with no difficulty. Okay, so let's continue to our last assumption. Our last assumption is actually easier than the third and the fourth. It simply says that this. No matter what's your type, okay, if you consume infinitely many units, your utility is not going to be infinity. Okay, your utility is somehow bounded above, and the most you may get, according to your type, is a function called v of u. Okay, V of theta. it's not so hard to verify this thing. Is that V of theta is increasing in theta. Okay, we have this because we have property 2 or 3. Okay, yeah, but this is natural. A higher type person, okay, he likes the product more, so that when they consume infinitely many items, they get more if they have a higher type. Okay, so that's the idea. So that's something for consumers. We describe their utility function and the assumptions they need to make. Okay, one example here, okay, is something you may want to use to verify that this satisfies the 5 conditions. Is the following: U of theta Q and Q theta. Okay, it's a function like this. You may want to draw figures or do those derivations to show that, oh, indeed, this function, this utility function satisfies all the 5 conditions. Okay? Yeah. Okay, not a big deal. Okay. Then let's describe how may a firm price, okay, with the different pricing plans. We know a firm has 2 ways to price the information goods. The first possibility is a fixed fee pricing. Okay? In this case, the company is going to charge T, and that's for an infinitely many or large consumption. Okay? You pay me T, capital T dollars, and then all you can eat. In this case, there is no cost for monitoring or for dealing with usage-based pricing. Okay, I forgot to mention one thing in the first video. We're going to call this cost for monitoring, for receiving payments, whatever. We're going to call this cost for dealing with usage-based pricing as the transaction cost. Okay? In this lecture, when you see transaction cost, that means the cost associated with usage-based pricing. Okay? If you are using a fixed fee pricing, then there's no such cost because everything is easy. You don't need to monitor what the person is doing, and you will have no difficulty to get money from him. Okay, so that's the case. Or if you want to do a usage-based pricing, then in that case, for each quantity, you need to specify a price. Okay? And as we have learned revelation principle or whatever problems we made, we know this will be a 2-part tariff for different types of consumers. Or we say in this case, what the firm needs to decide is a menu of contracts. Okay, we're going to say that for each theta between theta lower bar and theta upper bar, you need to provide them a quantity and a transfer. Here the transfer is denoted as tau. Okay, so when you want to use usage-based pricing, you are going to specify this menu of contracts to consumers. Okay, that's the idea. And in this case, you are going to incur a transaction cost, and we're going to denote it as C of quantity. Okay, here we allow the cost to be to be related to the quantity. It may be the case that a higher quantity requires a higher cost. Okay, but in here we do not make any assumption to C. Okay, except we say it is a non-negative cost. Yeah. So exceed the transaction cost. It's incurred only if you are or I should say, only if the consumer chooses the usage-based pricing plan. Okay? In this environment, let's specify the timing for the game. Timing is easy. There are just two stages of problems. First is the firm to decide and to announce their pricing plans. And then is for consumers to choose. So the first is for firm to price the information goods. The firm is going to decide the following things: a fixed payment, and then two functions. Okay? Yeah. So that's what the firm needs to determine. And after that, consumers, or I should say all those consumers, they will select. Select what? Each of them has actually three options. First is to select an all-you-can-eat plan with capital T as the subscription fee or as the payment. Or you may choose to use the usage-based pricing plan. But as we expect, this is going to be incentive compatible, and that's why if you choose usage-based, eventually in equilibrium you're going to choose according to your type. So we can exclude all other possibilities for false reporting. Or you may choose 0, 0, right? You may choose to do not buy this product, okay, and then get 0 utility. Yeah, that's still an option. Eventually, we're going to see that in the optimal usage-based plan, some consumers will be decide 0, 0. Okay, as a firm, I do not want to serve those consumers. They will also choose 0, 0. In that case, these two are just the same thing. Okay, so firms decide pricing plans, and then consumers select pricing plans. Here, the firm may actually decide whether to offer this option. Okay, if the firm does not want, to offer this all-you-can-eat plan, he can set T to be infinity. In that case, yeah, no one will buy it. Okay. Okay. So probably the last thing is to remind you, what do we mean by the schedule here is incentive compatible. So I'm going to write the constraints down. When you are offering this plan to consumers, if you want this plan to be incentive compatible, we need the following IC constraint. That means, as a consumer, if you choose the contract for you, it's going to be better than lying. This is the amount you may get if you tell the truth. This must be greater than or equal to the amount you may get by lying. Here we use T as the false report or the false type. Also, we need our constraints, our schedule to satisfy IR constraints. That means everyone will be willing to participate. Right? But actually you will see some of the agents will get 0, 0 as their offers. And actually some of them will be excluded from service. Okay, so that's the model. Then in the next video, we're going to analyze this problem and try to eventually get the optimal pricing plan. Thank you.